a burning building or some sort of household carbon monoxide poisoning. It happens once in a while, right? Sometimes happens. And the patient comes to the ER, of course, and it is taken to this chamber as a first line of treatment. This chamber that you can see from there is a cylindrical chamber. Patient goes inside, and then it closed it, right? And then inside the chamber, there is oxygen. Oxygen is injected, and the oxygen pressure about 2 to 3 atmospheric pressure. So what basically happened with that high pressure? Remember, we are all in a 1 atmospheric pressure. So what happened with the high pressure? Oxygen will diffuse into the skin of the patient. That will go inside the bloodstream, hopefully, and usually does, and it will replace the carbon monoxide from the blood. Remember, blood is hemoglobin. Hemoglobin is the iron 3+, and oxygen is bound to it. And because of the carbon monoxide poisoning, oxygen is displaced by the carbon monoxide, a very poisonous gas. Now, with a high pressure, 2 to 3 atmosphere pressure, oxygen is injected inside the body and basically removes the carbon monoxide. So that's the first line of defense. The only drawback with this technique, the patient should not be treated more than 3 to 4 hours. So that's the limit, because at that time otherwise you will have a brain damage or some kind of internal organ damage because of the oxygen pressure and high oxygen content. And it is usually the pressure should not be more than 3 atmospheric pressure, because they are at 1 atmospheric pressure. So patient, if you increase the pressure, patient will suffocate or will have a squeezing in the body, muscles, and etc. etc. So that's the only difference. Otherwise, this works very well for those patients suffering from carbon monoxide poisoning also. Okay, so that's the last applications. And then next one is our practice homework that you must work on it. All right. So must work on this practice homework, and these practice homeworks are, please write it down, take a copy, whatever you want to do it, and that is will be only in the screen. It will not be given in the slides in your file and in the blackboard. So first one, what are the fundamental basis of states of matter, molecular compounds? We talked about it, right? Read those slides, read those topics that we discussed. What are the intermolecular forces and what are their origins? For example, the 3 intermolecular forces we talked about, the weak forces. One is the London dispersion force, dipole-dipole interactions, and hydrogen bonding. And their origin is electrostatic. One is induced dipole interactions. Other one is a dipole-dipole. Other one is also dipole-dipole, delta positive, delta negative, right? And basically the order of the strength, hydrogen bonding is the strongest as compared to DD and compared to LDF, which is the weakest of all. Then explain, we talked about the LDF depends upon the several things, right? It depends upon the mass, size, shape, and one of the questions we asked, we entertained, I think we discussed, why 2,3-dimethyl propane has a lower boiling point as compared to normal pentane. Read it in your notes, it should be there, and you should be able to answer it if I ask the question. Another question that we asked, why the water is liquid and hydrogen sulfide, a cousin basically, same kind of molecule, H2O and H2S. H2S is a gas, H2 is a liquid. Why it is so? Explain, right? Other one, explain why acetone has a higher boiling point than normal butane. And then number 6, which gas law apply to the function of all pair of Planck's and how does it work? We talked about that, applications. Which gas law is applied to sterilize surgical equipment and how does it work? Last but not the least, how safe is hyperbaric oxygen therapy and when it is used, right? So read those and work on those. Questions we entertain, there are many questions we ask, and as we see before, whatever I tell will be there, one way or another, right? Now, we'll go to the next page, that is the part 4, and that is the classification of important molecular compound, the carbon base. So remember, carbon is in a group 4 element, right? It's a group 4 element. It doesn't belong to the non-metals, not a metal, not a non-metal. It is in the middle of all those group 1 to 8A, right? So we also explain why carbon cannot have C4 plus, right? It cannot have 4 plus, it cannot have 4 minus either.
So at that point,
what does it mean? The carbon, no way it can make any ionic compounds. To make ionic compounds, you have to be cation or anion, right? That's basically the our theme we talked about. That's a basic principle. Carbon cannot make any ionic compounds. It can make only and one and only is a molecular compound by sharing pair of electrons. And we have millions of carbon compounds, millions of carbon compounds. And all those carbon compounds are, many of them are naturally occurring. Nature makes it. Nature makes basically the air, the plants. The plants make it and we use it. And many of those carbon compounds are, in fact, our RX medicine, the drug. It has a bad ones, good ones, many of the, and as you probably know, the herbal medicines, they started from the plants. And all of them are carbon-based compounds. So we'll start with a very basic carbon compounds, very simple compound in this class, of course, right? So therefore, the first one, the carbon makes the compound is, so if you take, for example, let's say carbon, the carbon plus hydrogen, a simple compound will make. So carbon plus hydrogen, I'm not balancing, huh? We can make a compound called hydrocarbon. Hydrocarbon. Everything okay? Hydro means hydrogen, hydrocarbon. Hydrocarbon is a carbon and hydrogen compound. So hydrocarbon. Hydrocarbon means it is only C and H, nothing else, no other elements. And this hydrocarbon could be saturated. Saturated means, as you recall, probably there is no double bond or single bond. It could be saturated, right? It could be saturated, or it could be unsaturated. Unsaturated. All right, unsaturated means it has a double bond. It is a double bond or triple bond. The carbon-carbon bonds. So that's basically hydrocarbons. These hydrocarbons, that saturated or unsaturated, that we see, there are two major types. These hydrocarbons could be also two types by depending on the nature of the molecule. One is the linear molecules, just like a linear chain, linear, or it could be cyclic. All right. So these are the main types. So carbon plus hydrogen is the compound hydrocarbons. A blanket name, a big umbrella of this own kind. Hydrocarbons, right? Hydrocarbons could be saturated, meaning no double bond or triple bond, or it could be unsaturated, even unsaturated. It has a double bond or triple bond. Hydrocarbons are usually, in terms of the whatever saturated or unsaturated, could be linear or cyclic. All right. So let me give you first phase of the linear. We'll talk about the linear compound first. Linear, saturated, linear, unsaturated. With a double bond, with a triple bond. So next one. So general formulas of linear hydrocarbons are CnH2n plus 2. CnH2n plus 2. Saturated, that is all single bonds, no double bonds. And the structure of this molecule is X4 type. We'll talk about it in a minute. And it is a tetrahedral, 109.5 degrees. And the solubility is insoluble in water, but soluble in non-polar solvent. We'll come back to those properties. So the CnH2n plus 2, right? So that's the first one, the saturated hydrocarbons. N is the number of carbon atom. This N is the carbon atom. So when N equal 1, everybody okay, right? N equal 1, so C1, write the 1, and H 2 times 1 plus 2, that's a CH4. What's the name of the CH4 again? Someone tell me what's the name of this molecule? Anyone? What's the name of CH4? We talked about many times. Yes? Anyone? Methane. It's a methane, CH4 methane. And Next one, when n equal 2, so n is 2, H 2 times 2 plus 2 is 6. What's the name of the C2H6? Anyone?
Yeah, so it would be like your
Yeah.
alma.
C2H6 you can also write like that, CH3 and CH3. That's ethane. Ethane. Put it okay? Please write down. So methane.
No, it's not.
Next one is ethane.
Yeah, because this
Ethane.
part would be at the
And the
top.
next one, I think we gave some idea, some names. So n equal 3. So when n equal 3, so C3, H,
Which
2
is
times
the
3 plus 2 is C8. And that is called propane. Propane. It is a propane. Propane. All right? Remember a propane gas when you use for barbecue at the summertime? That's a propane. And propane is looks like CH3, right? CH3, CH2, and CH3. So that's a propane. And as you can probably see there, so the structure of these molecules are all basically tetrahedral. We'll come back within a minute. I'll give you some. So the next one is this one. The name of the
At
C4H10,
least you don't have
n
to
equal
go
4,
to next week.
H times 4 plus 2 is 10. It's a normal butane. It's a normal butane. Or you can just write like butane. And we talked about some of those boiling point and etc. when we talk about the LDF, right? It's a butane. And the structure and the schematic structure is CH3, CH2, right? CH2, CH2, and CH3. That's a butane. That's a butane. And if you know now who can tell me that it is a carbon number 1, 2, 3, and 4? What are the structures of the carbon number 1, 2, 3, and 4? So this is the one carbon number 1, carbon number 2, first one, right? Carbon number 2, carbon number 3, carbon number 3, and carbon number 4.
Plus
Who can tell me what are the structures? What are the structures of carbon number 1, carbon number 2, carbon number 3, and carbon number 4? Anyone? Yes? Yeah? You're there, right? All of you are there, right? Yes? What is the structure of carbon number 1, 2, 3, and 4? Anyone?
Is it a tetrahedral?
It's a tetrahedral. It's a tetrahedral. So basically you write like this. All of them, I'm writing the last one.
That's why I'm getting it
You
wrong.
write like this.
That's
See?
freaking humorous.
Remember that how we write the tetrahedral, right?
Why?
H.
How?
That's basically the bottom of the screen. And the next one is carbon. And you can do like another carbon, right? Carbon, 1, 2, 3, 4. 1, 2, 3, 4. And now basically what you do, you basically arrange those carbons like this, and the hydrogen, H, and H right there. The next one is H, and H, and you can also have like this is H and H. All right.
I
So
mean,
that's basically, sorry,
But, like, I
and
feel
then
like
go back to it. So another one is, you can put those of them, and now we can put the last one is H. All right. So you can see the right hydrogen on the plane, carbon in the plane, and it is top of the towards us, top of the screen, and it's the bottom of the screen. And you can continue like a zigzag form like this way, and all those bond angles that you see 109.5. 109.5 degrees, 109.5 degrees. So the tetrahedral, 1, 2, 3, 4,
Alright, so
1,
my
2,
biggest
3, 4,
question is, where's
1,
my
2,
cat's
3,
snake
4. These
group?
are all 4 electron regions are surrounding the carbon atoms, central carbon atoms. So they're all tetrahedral. They're all non-polar. Right? Carbon is hydrogen is 2.1 electronegativity. Carbon is 2.5. So 2.5 minus 2.1 is 0.4, less than 0.5. Therefore, all bonds that you see here, they're all non-polar bonds. There is no polar bond. Therefore, the molecule is non-polar. Carbon-hydrogen bond, less than 0.4, 0.55. carbon-carbon bond is a 0, 2.5 minus 2.5, 0. So whole molecules are basically non-polar. And what the, yes?
I just have a quick question. So you're saying that all hydrocarbons are non-polar because they're all made out of hydrogen and carbon?
That is correct. That is absolutely right. That's a blanket statement. Yes. And all hydrocarbons are non-polar because, as I said, non-polar. And usually the solubility, when you talk about the solubility, we'll talk about details later. Solubility means usually the polar compounds cannot mix with the non-polar compounds. Since water molecule is a polar, we talked about last Monday, and therefore these molecules are non-polar. So if you add the water molecule, they are all insoluble in water, but they are soluble in non-polar solvent because non-polar will mix with the non-polar and polar will mix with the polar, right? So that's the properties of the saturated hydrocarbons. They're all saturated hydrocarbons. Every okay so far? All right. Next one is CnH2n. So 2 is gone. CnH2n is a general formula. You call unsaturated hydrocarbon with a double bond. Unsaturated hydrocarbon with a double bond. And examples are, the first example, it starts with the 2 carbon, C2H4, it's called ethylene. So C2H4, when N equal to C2, 2N times 2, 4, C2H4. N equal 3, 2 times 3, C3H6. N equal 4, 2 times 4, C8. So this is the ethylene. That's our ethylene. All right. Ethane. Remember, ethylene. All right. Ethylene. So the counterpart, the saturated compound of this molecule is C2H6 right here. C2H6 is called ethane. A-N-E. Ethane. A-N-E. Methane. A-N-E. Butane,
I don't
A-N-E.
understand why we never have paper
This
cups.
molecule has a C2H4. C2H4 is ethylene, E-N-E. And the Lewis dot structure is, you already did it before, many of those we talked about. This double bond C, H and H. All right. So that's the double bond, and one of the bond is a pi bond, and one is and all the bonds are sigma bond. So that's a ethylene, E-N-E. The next one is propene. So P-R-O-P-E-N. Remember the ending. We'll talk about generalization very soon. Ending is E-N-E. And the saturated one ending is A-N-E. So alkanes, these are called alkanes. The saturated one called alkanes. Unsaturated with a double bond called alkenes, right? So the first one is ethylene, second one is propene, and the structure of the propene is CH3. You can put in the end or in the beginning, CH, double bond C, H, and H. All right. One of the bond is a single bond, one is a pi bond, one is a sigma bond. All right. So that's a propene. And the weight number goes like a carbon number 1, 2, and 3. So carbon. This is numbering system. How do you number? Always try to give the lowest number possible to the carbon with a double bond. So carbon number. If you start from numbering from this side, 1, 2, 3. Carbon number 2 is hitting the double bond. If you number from this side, 1, 2, and 3, carbon number 1 is hitting the double bond. Right? So that's a numbering system. This is the way that's the system as it is. The next one is the butane. Carbon number 4, analog is analog. Saturated one is C4H10. Butane, A-N-E. Butane. It's a butene. Why butene? It's a double bond. So butene, right? So E-N-E. all ending with the ENE. So unsaturated hydrocarbons, the double bond ending with the ENE. And the names are basically following their alkane derivatives, the saturated one. Methane, we don't have a methylene, CH2, because there is no, you can have carbon always have 4 bonds. So it always starts with the carbon number 2. Let's say ethane, ethylene, propane, propene, butane, butene. And the structure will be very similar kind of. You can write like CH3 as usual, CH3, C. You can put the one double bond right here. And you can also put another one, CH3 and CH3. All right, and H. All right. So this is the butene. Now this butene, you can have this. So carbon number 1. Either way you can do it. 1, 2, 3, or 4. Either way, it's fine. It's basically the same thing, right? It's a symmetrical molecule. Now, this molecule could also have like this. It is like a CH3, CH, double bond C, CH3, CH3. You can also have molecule looks like this, same molecule. And you are going to tell me what it is. CH, double bond C, H, and CH3. So what's the difference between these two molecules? Can someone tell me what's the difference? Let's see, carbon number 1, 2, 3, and 4. What's the difference between the first one and the second one? Who can tell me? What's the difference? There's some difference there. All right? Yes? So butene, for example, you can have other things too, but at least these two are very important one. So you can have CH3, CH, double bond, C, CH3, CH. You can also have a CH3, C, H, double bond, C, H, and CH3. What's the difference between these two? Who can tell me? What's the difference between these two? Yeah? Anyone? What's the difference between these two molecules? Yes?
CH3 right next.
So two CH3 groups are on the same side, is that right? Yes?
Oh, fuck me. It's only
Both
11:30.
CH3s on the same side.
Still got 20 minutes.
And these two CH3s on the opposite side. Tell me yes or no?
I might have to go to math class.
Yes?
Yes.
And tutor.
So this is called cis configuration. That's a cis. Cis butene. Cis
What?
butene. And how about the next one? Okay, someone is changing it. Please do not change it, okay?
I was like,
All right.
I need
So
something.
cis butene. Cis
I'm
butene.
not gonna throw up.
What's this one then? What with this one? Does anyone? Trans. Trans means opposite side. It's a trans configuration. So the same molecule, same molecular formula, same double bond, but the orientation of those molecules of the carbons could be different. And based on that, you can have a cis butene when the CH3 molecules are on the same side, and or it could be the opposite side is a trans. Trans means opposite side, cis means the same side. Is it okay? So that's a butene. These are the saturated unsaturated molecules with the hydrocarbons unsaturated with a double bond. And if you look at the structure of this carbon number 3 and carbon number 4, so carbon number 3 and carbon number 2, this you can imagine a triangle. Same thing you can imagine this triangle as well, right? You can imagine another triangle like this with this carbon. So it's a AX3 type molecule. All of them are AX3 type, and therefore the bond angle is 120 degrees. 120.
Professor Dada,
Yes.
for the saturated, the all single bonds at the top of the slide, you said
Uh-huh.
that n equals 1, correct?
The first one is n equal 1.
I made too many.
Second one n
apples.
equal 2. Third one n equal 3. Fourth one is n equal 4.
It's been stuck in my throat.
N
Okay,
is the,
okay.
n is the number of carbon. N is the number of carbon.
Tequila.
N is the number of carbon.
Okay, thank you so much.
You're welcome. Your unsaturated one,
And
n
you were
is
the
the
one
n
who
number of
wanted to
carbon.
do shots.
N equal 1, ethylene. Sorry, n equal 2. It starts with a 2. N equal 2, ethylene. N equal 3, propane. N equal 4, butene. The next one will be n equal 5, pentene. And you go on and like this way. All right? So once again, the hydrocarbons with unsaturated with a double bond, unsaturated hydrocarbon with a double bond, they're also non-polar. They have a bond angle, they are also AX3 type, the triangular planar. Because of the double bond, they're planar. They do not have a three-dimensional structure itself is a planar structure. All right? And if some other molecule, once the carbon number hits to 4, butene, it can have a cis or trans configuration. Cis or trans configuration. Cis means the groups like a CH3 group, or some other groups are the same side called cis. If those groups are in the opposite side,
want any
they
apples
call
and peanut
trans. They call trans. All right. The next one, the last one, also the hydrocarbons, with the unsaturated hydrocarbons, and the general formula CnH2n minus 2. CnH2n minus 2. N is the number of carbon. N is the number of carbon. When carbon number is 2, starts always with the 2, unsaturated ones, is C2H2. C2, 2 times 2 minus 2 is C2H2. C2H2, its name is acetylene, or you can say ethine. It is called
Located at by
acetylene,
phone.
or it's called ethine. I'm going to put it like this way,
It said your advising
ethine,
appointment is located at by phone.
Y
I was like,
N-E. Y-N-E. This is Y. So ethane is the mother molecule,
me?
the saturated one. Ethylene, right?
when you
Ethane,
do that to
ethylene,
you.
the unsaturated is a double bond. And ethine, E-H-Y-N-E, ethine. And the structure of ethine is C-H-C, a triple bond, C and H. All right? It is also known as acetylene. It is another name of its own, trade name, acetylene. And it has a triple bond, and one bond is sigma, all the sigma bonds, and two of these triple bond is the pi bonds, all right? Ethine. The next one is propyne. Next one is called propyne. So the C3H4, carbon number 3, N equal 3, and 2 times 3, 6, minus 2, 4, C3H4. C3H4 is called propene. It's called propyne. So propyne, P-R-O-P-Y-N-E, propyne. And the structure is CH3, C, triple bond, C, H, CH. So that's a propyne. And the next one is C4, carbon number 4. So N equal 4. 4 times 2, 8, minus 2, 6. C4H6. And that is called butane. All right? Butane. And the structure is CH3, C, triple bond, C, and CH3. That's a butane. So now tell me, what's the commonalities between these unsaturated compounds, the triple bond? So commonalities of the unsaturated saturated compounds, A and E, ending with A and E, methane, ethane, propane, butane. Unsaturated with a double bond, ethylene, propene, butene, pentene. Unsaturated with a triple bond, ethine, propyne, butane, pentane. So what's the commonalities? Yes? What's the commonalities of the unsaturated compounds, the triple bond? They always ends with YNE. YNE. So first one, saturated compounds called alkanes. So first one, the saturated compounds are called alkanes. Alkanes, the general formula, general names. ANE, alkanes. So general formula of the alkanes is CnH2n plus 2 alkanes. All right. From these alkanes, if you take one hydrogen off, that will end up with a CnH2n plus 1. Cn plus H2n plus 1. All right, CnH2n plus 1, and that is, so if you just take one hydrogen off from the original molecule alkanes, and that is known as alkyl group. Very important, please write down. And it is always usually represented as R. So the general formula of alkanes of the hydrocarbons is RH. RH are the alkanes, right? Because you took one hydrogen off, you just put it there. So RH are the general formulas for all alkanes. So alkane, general formula of alkanes is CnH2n plus 2. General formula of alkenes, this alkenes, right? So the first one is alkane. The second one is alkene. AENES. So last one is ENE. So CnH2n plus 2 alkanes, CnH2n alkenes, and CnH2n minus 2 is alkynes. Right? YNES. Alkynes. So alkanes, saturated, alkenes, unsaturated the double bond.
That one hurt.
Alkynes, unsaturated the triple bond. YNE, ENE, and ANE. Alkanes, if you take one hydrogen off from the molecule, is called alkyl groups. Now, can someone tell me methane, CH4, what is the group? So methane is CH4, the first one. If you take one hydrogen off from there, you get CH3. Can someone tell me what's the name of the CH3? The name of the CH3 is methyl group. Methyl, THYL. Alkyl, methyl. Methyl is CH3. So who can tell me what's the name of this group? CH3, CH2. What's the name of this group? Come on, tell me. CH3, CH2. This line indicates the hydrogen is gone. It initially had a CH3, CH3, alkane, ethane. So what's the name of the alkyl group? Methane, CH3 methyl group. CH3, CH2, what's the name of this? Anyone? Yes? What's the name of the CH3, CH2 group? CH3, CH2 group. It's alkyl group. Anyone?
Is it like ethyl or ethanol?
That's right. That is absolutely right. Ethane, ethyl. Methane, methyl. Ethyl, ethane, whatever you pronounce is okay. ETHYL. That's right. It's ethyl group. So now, tell me what is this one? The next one is CH3, CH2, and CH2. That's a group, alkyl group. If you put CH3, CH2, CH3, that's a propane. So what's the name of this group? Yes, what's the name of this group?
Is it a propyl?
Propyl. That is absolutely right. PROPYL. Yeah, that is right. So what is the next one? What is the next one?
I feel like I'm dying.
Yes? Carbon number 1, methyl group. Methane, methyl group. Carbon number 2, ethane, ethyl group. Carbon number 3, propane, propyl group. Carbon number 4, what's the name of the molecule? Carbon number 4 is butane. 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 So what's the name of the group then? What's the alkyl group of the butane? Yes?
Butyl.
Butyl. That is absolutely right. So what is the name? What will be the next one? Can someone give me the next one? So methane, carbon number 1. Ethane, carbon number 2. Propane, carbon number 3. Butane, carbon number 4. After that, you basically name the carbon according to the carbon number. Carbon number. So if you have a C5, H12 is pentane. Penta is 5, pentane. So methane, ethane, propane, butane, pentane. P-E-N-T-A-N-E, pentane. Next one is hexane. Next one is heptane. Heptane. The carbon number 8, octane.
That's the only grade.
Carbon number 9, nonane. N-O-N-A-N-E. And the last one, carbon number 10, put it up, decane. D-A-D-E-C-A-N-E, decane.
I don't even remember what I got.
So pentane, hexane, heptane, octane, nonane, and decane. And their groups will be pentyl, hexyl, heptyl, octyl, nonyl, decyl. Right? YL, alkyl groups. Alkyl groups. Usually these alkyl groups are only for the alkanes. Alkenes or alkynes who do not use those groups, but there are some. They have different names. So we are not going to go to that complexity again. So all alkanes, the alkynes are the AX2 type. The bond angle is 180 degrees, and all hydrocarbons are non-polar. Therefore, they are insoluble in water.
The rest of the
Always the
bottle?
solubility
You said
means
don't-
whether they will dissolve or not in water. That depends on the polarity. Alkane or the hydrocarbons are
That's
non-polar.
because we're going into
Therefore,
lockdown.
they are not soluble in polar molecules like water. They are only soluble in non-polar molecules, non-polar solvents. All right, so that's basically the molecular compounds with linear
Yeah.
hydrocarbons.
I didn't read it, though.
Linear hydrocarbons. We can also have the cyclic compounds. And now someone
Because I
must
know,
be. Now, can I
My
can I
friend
get
said
out
that
from this
Thursday
slide?
something was
It's
supposed
okay.
to
Everybody has it.
Anyway.
Yes. Any questions?
I don't know about you guys, but I don't know.
Any questions from this slide? Yeah.
I don't want to go.
Okay. If not, so these are the hydrocarbon, carbon with hydrogen, carbon plus hydrogen makes the hydrocarbon. Hydrocarbons are two types, linear, and linear molecules
Everyone can move into my
are three
room.
different groups. There are first group CnH2n
We
plus
just need
2
Bliss's extra
called
for the
alkanes.
floor.
CnH2n called alkenes. CnH2n minus 2 alkynes. And alkanes, CnH2n
We're
plus
in
1,
camp.
if you remove
You
one
can come
hydrogen,
over.
But
it's
by
called
all
alkyl
means, come
groups.
on over, Ho.
And the name of the alkanes are usually the mother compounds. N equal 1, carbon number 1, methane, carbon number 2, ethane, propane, butane, pentane, hexane, and it go on like this way. Unsaturated with a double bond, it starts with the carbon number 2, ethylene or ethylene, right? Ethylene, propene, butene, pentene, hexane, and go like this way. ENE stands for the ENE. So root word is, for example, propane, P-R-O-P-A-N-E, right?
probably green
Propane,
and
prop,
gold.
so P-R-O-E-N-E is propene. So just change the A-N-E to E-N-E, you get the unsaturated double
I
bond.
didn't like that.
If you get the unsaturated with the triple bond, it will be stands the Y-N-E.
Goodbye.
Ethine,
I'm sorry.
propyne, butane,
We're in camp.
pentine, and so on and so forth. All right. So now we'll go to the cyclic molecules. So cyclic molecules with a let me go to the whiteboard. I don't have much space there. So let's go to the whiteboard. The cyclic hydrocarbons. All right.
Professor Data,
Yes.
I had a question on the last slide.
Yeah. Go ahead. Tell me.
When you did like the cis and the trans
Uh-huh.
examples,
Yep.
how are you able to have like the CH3 in that diagram?
Come on, treasure.
I mean, one, if both CH3, the both methyl group, we know the CH3 is a methyl group. If the both CH3 groups on the same side, a cis.
This smells like cooked taco.
If the CH3 groups
See, I
are
don't smell
opposite
it
sides,
anymore, but well, after like last night when I was like cleaning
trans
up my
is opposite,
Oh yeah, she vacuumed
cis
us.
the same side.
at 11:30, like
Yeah, I understand
the floor
that
was
part.
like walking
How
like
is like
lava.
These videos are scary.
CH3 allowed in that diagram?
Singing into the trash
Meaning,
can.
That was funny as
meaning
fuck.
how you write it, or what is question? Please tell me again.
Isn't that like a
Sorry, Mom.
compound itself, like CH3? What is?
Don't stop licking the poop.
Are you only allowed to have like a carbon or a hydrogen?
So it can if you this is the only say butane, but if you have another molecule, they have a different structure. Yes, different. So it depends on the molecular formula first. So now if you
Oh my
have
God,
like
guess what
this,
sound they took
so
on
it is a
TikTok?
C4, right? Carbon
No, they
number
did
4,
not.
And C4H8.
Oh my God, that
C4H8.
angle, I don't look as
So
strong
if
as
you have a
I think I do.
C5H10, then that will have a different structure. That will also will have a cis and trans too.
That.
Is
What
it
were
your
you
question
asking?
or this is your cis, right?
What do you want to keep in here?
Yeah, that's
What do you
good.
want me to take back to my
Yeah.
I'll take all the margaritas.
So in other words, if you go to the next molecule,
I
for
don't
example
care.
I'll put them in the
C5,
ottoman.
that will
We
also
can
have a
leave
cis and
everything
trans.
here. It doesn't matter.
And the
to me.
structure will be different, right?
Mm-hmm.
I don't necessarily.
Yeah, for example,
I
let's
have
say-
I don't either.
I have a question.
I mean, they're
off
just
of that.
chilling in that
Yeah.
thing.
Okay, so I understand like the whole cis and trans thing, but why don't you have to break up the menthol group? Like, why is it allowed to stay in another compound within
I don't know if you
the
want to take your margarita glasses
butane
with you, if you want to
or
take.
butane group?
I don't know where I'm gonna put them.
So
And if I'm going
so
home,
basically
I'm
what
gonna leave
happens,
it
so
on the
remember this is a
alcohol
planar
with
molecule,
you.
right?
You drink it, I don't care.
So in the
Right.
Queen.
planar molecule have a
Said
two
you
different
can-
configuration.
I don't care.
Configuration means the arrangement of the groups or atoms.
Liz, why didn't you
So
buy
in
them
this
from
case,
Walmart?
when the CH3 on the same side,
Her ankle was too busy getting run
also
over.
have CH3
Sorry.
on the opposite side. For example, it's a CH3,
My mom
C,
goes, "You're so cute and smart. I
H.
love you."
double bond.
I'm literally
And
sitting
you
here
can
not
see,
in Kevin class.
now
Like I
this
told her I
element is not the
was
same.
with
This
a C
element is not the
plus.
same as the first one. So first one is a cis,
Hey, we got our anatomy grades
Right?
back up.
That's all
This
that
is your
matters.
class.
Now we just need to work on
Now,
Chem.
this is the
We'll be fine.
arrangement
I got
of
it.
those
I got it.
arrangement of the
I
groups.
know.
So in this
I
case,
know.
I
methyl
don't know
groups
how
are in the
ADHD
opposite
is
side,
in his class,
and
though.
this case methyl groups on the
I
same
love
side. Yes.
Because at my school in 88.
Yes, I understand. I understand that part.
How do I look?
But like,
You look
Pretty
put
good.
together.
You
I
look
look
why
fine.
I
isn't
woke
the
up
carbon of the
I woke up at
butane
10:55.
after two
or
margaritas.
You were up at
Menthol
9:30. It's been 2 hours, honey.
It's been 2
have
hours?
3
Yeah.
hydrogens?
Oh.
Or
Well,
rather,
actually,
like,
I woke up at
can
8
use it as
o'clock,
one
fell asleep, woke up, ate it.
thing
fell
instead of
asleep,
making
woke
the
up,
structure
fell asleep.
bigger
Your bed's
and, like,
really comfy.
breaking it apart.
I know you were sleeping on it
Well,
last night.
this
So you
is
did all
the
night.
this is the molecular formula, and this is the structural
Yeah, we have, like,
formula.
2
Structure
jars
means
of-
the way they are arranged.
Jars of
If you want to
Tostitos
put
cheese
this
left.
one, you can also do the same thing. Like you can put like this. You can
I mean,
put
I don't like
this.
this
You can also do
cheese. Y'all
the,
can
that
just
one
have
too.
that. Can I have
Like
the
this
salsa?
one. Rather than if you put it like this way, it will be too clumsy because
Your
you
chips
will too
are
many
in my
groups up
closet.
there. So that's why you put the R groups. R groups are separately
Yeah, I use
altogether.
that too.
So basically,
Then I
general
need to go get
formula of the
fucking
cis and
tortilla
trans
chips.
it goes like this way. You have a R group is a alkyl group, and you can put like this, and this.
Actually, I want to
C,
keep some of the
R1.
salsa because I was planning on making a taco
R
salad.
and R1 are,
leftovers,
are
and that
not
would
the
slap.
same or could be the same. So now
Literally just like a
we use the
tablespoon.
R
Calm it
groups, so
down.
methyl groups is CH3 all
Don't give me
together
that look.
just to represent the R groups.
No.
If the two R groups on the same side,
I don't know.
the cis,
Dude, who the
and
fuck
if the
knows
two R
what's
groups
left
on the
on this
opposite
floor?
side,
Oh my god.
it
It's a
trans.
piece
So
of
that's the general formulas of the cis and trans configuration.
In the fridge
Configuration
or in the
Okay.
freezer.
The
I'm so sorry,
arrangement
you
of
just cleaned
those
the
groups or
She'll eat
atoms.
it.
Okay,
Oh
so
my God,
technically you
she
could break up the R group
loves
like
it.
you did on the
Liz, open the
structure
freezer.
diagram
Get
on the
rid of
left.
bowls. That's
But
not
you leave it as
or
a
the-
single R group just for like sake of like understanding what it is.
That is correct. So you can break it up into hydrogens
No, no.
on R groups, or you just write the R groups as it is. So for example, let's say you can also have a molecule looks like this. For example, let's say you have a CH3,
Because it helps to not brown them.
CH,
What if they get
and you can also have a C,
Wait a few minutes.
H,
That brazier is not that powerful. Do
and
you want some peanut butter?
CH2, CH3.
What?
You can also have a multiple
Homegirl
like
just
this.
ate that. I was like,
So now tell
You
me,
went full
so this is the one R group, right? What is the R group?
What
This
is
one?
can I have some peanut butter?
That's methyl, right?
And what is this group?
Do I just
Yeah,
eat
that is
it
right.
out of the
Is this group?
That's what I did.
Queen shit.
Ethyl?
Methyl. So you can have a methyl, ethyl,
Oh my god, Liz, what the fuck is
and it is cis
this?
configuration. You can also have a this is trans configuration.
like
You can
not
also have a cis
matching up.
configuration. So basically, whenever you
Because we're
write
not
the cis and
very
trans,
Jesus
you use the R group.
You saw the apple on the ground.
But you can split it. You can split
Queen.
into the real configuration. For example, this CH3 has a tetrahedral structure, and this carbon number 2 has a triangular planar. And this CH3 also has a tetrahedral structure. So this is a combination of two different types of structure as well. So this is called configuration, the arrangement of atoms or groups. Groups means alkyl groups in a molecule.
Really don't
A
want
molecule.
it
All right, looks like we're
Okay.
done. Yeah. Is it okay?
Where's my phone? There it is.
All right. So now next one we'll go to cyclic probably on Friday. All right. All right. Let's see. Anybody have any questions? I'm still here, right?
Cam's over.
Okay, thank you.
Stay there and.